we need to get the screen working here, but in the meantime, I could start to sort of introduce the session. So, like I said in the previous one, we've been sort of looking at sort of this, or having this discussion around modernization since 2017, or maybe early 2018. We've had a series of discussions when the linked data community came to buildingSMART to look at different ways of encoding things. And what was always missing was sort of a discussion around the sort of, I think you brought it up. I'm going to blank on your name, and I know your name. I'm looking right at you. Yeah, Michelle. The discussion about architecture versus encoding was always one of these discussions. And one of the things that came up when you looked at the linked data community that was very active for a while in buildingSMART, and you then looked at the software world, there's a community of people that use linked data, and then there's all the CAD tools and the system architects that work in the sort of day-to-day tools we have. They don't interact all that much currently. And so the thing we've been trying to figure out for quite some time is sort of a way to mix these two worlds. Is there a software architecture that starts to solve the problems that the linked data world has solved in its representation? And is there some overlap in the world of what the AEC industry is doing as a whole? And so that's sort of where this presentation kicks off. So the first thing I wanted to just talk about is one of the challenges, I think, is the technical room. We're not responsible for a quote unquote product in this room. And this is a distinction that's, I think, important, at least from my perspective, and that if the community wants to use IFC for digital twins, it's a capability they're asking for. What a digital twin is not my responsibility to sort of define, or technical room or Dennis's, but it is the capabilities they're asking for are things we should aim to have in our data standard. And there's a whole host of things that look similar. And so as much as possible, if we can look for commonalities on how to solve these problems, then that's the work we should be doing on how to modernize the standard. It's pretty straightforward, I think. Questions? No, probably not. Okay, so we talked about this sort of previously. I think we can just skip past this. So when we had our meeting in Zurich, this was a sort of smaller group of the technical room and, technical services team and some others. We sort of walked through, well, what are the functional things we actually need to solve if we start to look at modernization? Sorry. Well, so the first one was around sort of change management, not the fact that we needed to solve version control in the data set, but just simply this fact that today, every time you publish an IFC data set, it's basically invalid every time you publish the next one, because we don't have a sort of update functionality. We don't have change management in a sort of that respect. What we really need is an ability to sort of support, and I think support is the right way to look at this versus sort of invent version control, is how to do such a thing that you can have an additive process. And that can be additive in a linear, but also I'm assuming we have to really cover branching workflows, like building exists, it's being renovated, so you have two states of the data functional at the same time. And then we have this sort of multi-owner problem, and not from many people own a building, but from specific data types. And there's very few that don't have multiple owners in our industry. But if you look at something like a light fixture, it could be that during the design process, an architect owns the location. I will say this is, no one can work this way because the tools don't think this way at this point. But really, if you're thinking about bringing together data sets that's defined by multiple owners, these are the levels you start to think about breaking them apart. So like location, performance might be sort of managed by a lighting designer or interior designer, electrical engineer. The actual systems for that element might belong to the electrical engineer, or if it's a low voltage provider, and so on. But what you see in a simple quote unquote light fixture, you already have these at least three potential owners of pieces of the information. And then on top of that, if you're trying to sort of plan what you'd call pre-construction in some parts of the world, the contractor might be trying to purchase that associated with their product. And then finally, if this is actually already occupied or part of a sort of a pre-construction going into operations, there's asset management work that needs to be done. And currently, the way you have to solve this is someone has to assemble this data as it comes in and either replace it or basically manage different copies and change between the copies versus allowing it to be defined in exactly the way it's shown on the screen, which is having at least 5 bits of data owned by individual groups of people. No, I would call this a project-specific view of the world. Like on this project, we have a lighting designer, so the lighting designer is going to do it. Or this contractor in this part of the world uses this kind of labor to get barcode information. I don't think this is. I think this is needs to be very flexible. And I saw David react to that question too. Sort of, there's a. Yeah. So just for everybody online, it was just a question of clarification about, yeah, is this a model? Would something like this be part of a model view? And there was clarification, but it really pointing to, no, this is very dynamic, probably project or company or workflow specific sort of views of the world. And then on top of that, the reality is even for something as simple as a floor slab, there are a large number of pieces of information that if you sort of actually looked at the reality of it has multiple owners again. So this is just a different way of showing the same thing. And if you were trying to solve this problem, you'd realize it's a multi-part problem. It's a linked problem because, like if you were to follow this through on the screen here, like, a floor slab has an architectural component and a structural component. They're not defined well abstractly, but there certainly would be able to be defined at a project level. And then you have other pieces of information that, on the material side that is actually becoming more and more important that, like material attributes independent of life cycle cost data or carbon data, these things that are sort of part of the same thing, but today we treat them as separately and distributed, and obviously because this isn't one party. And then finally, multi-graph, if you were to think about this, because realistically, if I showed this slide, there's a microcosm of each one of these for each bit of data you have. So this would be the simplest concept that you could express in this model. I'm a thing and I have an ID. And I was instantiated on this. And so I did this sign example because we actually got an example from someone in the UK that's saying asset owners are starting to do something where, okay, here's all the IDs for my assets. I know you're going to build me a road. Make the link to these assets as you do the design, and it's going to come back to me and it's already going to be complete. So this is the basis of starting something exactly like that, I have this sign and you're going to actually have, 50 of them. And before I give them to you, I'm going to do a couple things. I might say add a relationship and add a classification. So I know that these signs are however I want to model this data internally. But before I give it to a customer to sort of add on to it, and this is very much the way to think about it, that I've already set up the relationships to the data. So it's not new, it's just it becomes an additive process, and we'll have to talk about what that means. So in this kind of model, to solve the problem of, and maybe this is actually what you were talking about, a view, David, you very much have to think that there's no such thing as a file, but you do have to have a way to collect information together. So you could call that a collection, a scene, assembly. I don't know what the proper terminology would be. There's an echo somewhere. But the idea is like it becomes a directed graph, I think is the way to think about this in a practical sense, that, you know, the scene knows about these things. These things can be part of many scenes. So you can't have these entities store their relationships. I can't know what scene I belong to because, you know, the signs as they are in this state could be many, and as we move forward, we'll see how that works. So what you're actually doing is you're transferring that to the design process, let's say, but what you'll notice here is what you're able to do based on need and permission and whatever business requirements is, you might not want to share your internal classification, but you just want to share the entities. So it's important that you can, here's the thing that is going to link back at the end, but in sharing those, I can give you a copy of the scene, the assembly, what have you, but it's just the entities and not the components. Or it could be some of the components. It's not explicit in the way to think about this. And I'll skip this slide because I think we need to come back to it. But when you share them, it's important, and I'm putting, this was during the security, somebody was mentioning security and that during the call, so or during the presentation, so I was just basically pointing out what, this is where we'd either use a system to manage version and change control, or you could embed it in the data to, you know, if we standardize on hashing or something like that, we think is the best way to do that, we could do that. But basically what you're saying is this copy should be exactly the same as you transfer it into the stream. So then we're now in the upper right corner, we're in the design scene. And so what you're seeing is, well, I have two signs. So I have two pink boxes, and then the circular objects I'm showing here are different components. And this is quite different in the fact that it probably makes a lot of sense to make small components that have very different functions, that have different functions versus treating them as like all the parameters. You know, parameters owned by a group might be the right component size, or it could be one parameter is the right component size. But so you have separate information for location, geometry, you know, materials. The key point of this sort of approach is that they don't really know about each other at all, and that's intentional. Like the location, the geometry can be related through a relation, but you can change the geometry without manipulating the location, the material. I mean, there's some things that are illogical in that approach, which adds some complexity, but also adds the fact that you can sort of distribute a definition, and so multiple people can make it as you go. And so my little blue circles are just representing parameter or property information. So we have two signs, we have an alignment. This is how, you know, sort of want to think about the world. Again, these magenta rectangles are entities in this model. So what we have is a sign, we have two posts, and we have two foundations. You can do things like, still do things like having type concepts, types within the data, not types of things. And we'll have to talk about what that means. And so you can do things like, well, actually my location is a linear location, and that inherits from the type. Again, this is one of the interesting things like when you explore this model is these are much easier to add dynamically as the standard develops and grows, because it has very little effect on anything else. You certainly have to have, if you want to use something like a linear location as a concept, you have to sort of interpret it software. But if you wanted to add a new one, like a linear array, it has, you know, sort of no effect or no requirement on any other pieces, except that you have, you know, consistency in the information. I'm being sort of speaking very high level about this because there's certainly things you have to consider. So as you sort of move to the right in this sort of approach, what you actually get is, you know, I have the type of linear location. I have a location that's specified in the alignment. I can have multiple pieces of geometry in a single alignment in this model, because you can have an arbitrary number of components. It's intentional. And then you can sort of create relationships, which I'm not really showing here, which is just another kind of entity that sort of makes this specific relationship between components. So you have, in this model, you actually have really three things. You have entities, components, and you have a scene. And very simple approach to modeling this. But the kinds of relationships you have are component to component, component to entity, and entity to component, which is, well, so the entity, Dennis is asking the question just with the clarification. The entity is a dataless identifier. It's a root. That's it. It's like a naked root, basically. Yeah, a container. Yeah. And so like the key part of this model is there's nothing in it of business value. All of that is in the components. So if you're adding, sort of, I said linear location is a thing in IFC today. We have linear element, which specifies this element is a type linear. This is just similar, like the idea that, well, placing things linearly is a concept that we would have to replicate and just illustrating it. But the idea that you can make, an array-based placement logic, sort of geometric groups, what have you, is doesn't interfere with the other things. So if we're going back to this multiple ownership sort of slide I showed in the beginning, that light fixture, and it was from an old presentation, so otherwise it would all be signs, but we'll have to mix and match. So we have the sort of client to the design process. We have the sort of design process where they're making new entities and new components and new properties that are also components. Then you sort of would, if you're handing that off generically into a construction process, what you're actually doing is sort of making new scenes, views, assemblies, what have you, and making the decision about which, certainly the entities have to flow no matter what, but you can make decisions on which components can move through. The key thing here is what you're actually doing is, instead of thinking about it as a transfer, you're making a link. It's a forward, sort of directionally forward link. And so when you get to this sort of final step, the operations team can, this information still can be changing during construction, but they can be adding other system information on top of it, adding group information. And that definitely is part of the scene and not part of the object. And we can talk through the logic of that. But if I'm a rail entity and I want to have a spatial view of the world that's based on the rail part of the business, and have a building side of the business that wants to think about it, a building view of the world, you shouldn't have to control all of those views of the world, if you will, the sort of spatial context from one location. It's something we'll have to think about, but it certainly looks like the direction when you push on it a little harder. And finally, what you have is you essentially have round-tripped this information, and it became an additive process versus an information exchange. You're still exchanging information, but I'm making the distinction that essentially what you're doing is sort of building from the inception versus fully, you're enriching it is probably the better way to look at it, versus having to replace it every time, which is often how our exchanges work today. So there's other, all kinds of different things that you realize in this model, because there's intentionally very little interaction between the components. Adding new kinds of components is a standards task, and it's a software task, but it intentionally should have very little effect on the rest of the world, if you will, of the standard, which means, I think anything we're talking about in short term, we would, certainly not throw away the step representation we have today for geometry or anything like that. We would just be able to use them, but as sort of voxel representations, or if we wanted to introduce GLTF or any of these things for mesh representations, these become sort of add-ons and extensions that don't have to be as well coordinated with the other things, and that's a benefit, and it's a challenge when it comes to a standards body to sort of handle. And then, like I'm glad you're here from Schneider. One of the things that it's important is this model actually does a very good job of sort of setting up the ability to sort of share definition and actually work in a sort of graph database or linked data world or any of these sort of combined views of different schemas, and the fact that because this entity is all you need from a, let's say I need to make that sign becomes a point in a GIS maintenance system, it's just a single pointer, and it can be a remote component of that information. And what you realize is that the big challenge with this approach or solving this problem is how to handle everybody can have you want everybody to have a copy of the entity. It's the same, right? It hasn't changed, the ID hasn't changed, and that you can either have live connections from other data sets, or you can have offline connections to those different data sets, but then you need to be able to assemble them. And the thing we have in buildings that are maybe not as challenging as the GIS space is we have these logical relationships in buildings and infrastructure, right? Like if one data source on my right hand is the level structure that the architect defines, and I'm the structural engineer over here on my left hand that I host my beams on, we need to have a method by which we keep consistency of those things. And that's a challenge with any distributed data structure that we have to think about how to solve exactly that. So the model, this ECS-based approach lends itself well to that, but it also means we have to have a way to communicate between systems, no matter the technology we're using. So as I said, you need to you need really three parts of the picture. You need this scene assembly concept, you need an element, and I must have been dead yesterday because it's entity, not element. I think I probably copied this, that's why. And you need a component. I'll fix these slides before I give it to anybody. When it comes to how do you make typical things, instead of thinking about a class idea, you really start to look at, well, this is actually my sign. What you do is make for lack of a better way of saying it, just a template, what a sign looks like when it's complete. It has a location, geometry, and it has these properties. It's not a class in a classical sense. It's really, the schema helps you define what a fully defined sign would look like. And this actually concept is quite important, I think, as we look towards, you might say IFC was sort of originally developed under the notion that you could standardize everything, but every time you go to a country level, like we heard in Zurich while we were there, that, well, they actually have totally different names for everything, but the concepts are the same. So the idea that you could define it's not quite the same as a concept template as we have in IFC today, but that this could be classified, named, and linked to our standards in the way the data represented, but you could, call it and sort of talk about it any way you felt was relevant, and you wouldn't be breaking the standard. There's a lot there in how we solve some of the sort of more complex topics of reusability, but there's, yeah, go ahead. Sorry, I'm talking too much. Yeah, I think that's, not architectural, Australian design sign for IFC, not GIS, right? You're basically pointing to the problem that, like, the second this can become huge, templating becomes hard.
Well, I guess it's is the concept here, which I can get around, that we would have many templates.
When, again, I don't think buildingSMART would be in the business of defining 90% of them. Some of them, absolutely.
Right.
Yeah.
I would agree with both of those statements.
David.
So I think that's really interesting when you break it out this way, right? First, the standardizer. So with these components, it's really easy to layer
Right.
templates.
Well, and again, that's the thing. Like you can have, we'll show the next level. You can This architecture allows for an infinite level of flexibility in that respect in additivity.
Whereas the project standards,
Right.
Like this one-off project says, we're gonna have these two components on all of our things, because we've decided that we need this information.
Correct.
What's the notion of its IFC sign? Is that a component? Is that a component?
Well, I think that we actually can come back to, like, is BSTD the thing that just tells you this is a sign from a building smart perspective, or is it like going all the way back? Like I'm not going to try to decide.
Type defines, sets the stage for the necessary components. So is that
I think it's a concept outside of the yeah.
Any component systems come from massively multiplayer worlds, right? And the third component, the third piece of many component systems, is not an entity component system. There's entities, there's components, and there's systems. And so there's a rendering system. This rendering system does not care about anything's type, anything types. It just says, give me all the objects with a renderable component, and it has an interface that has data and I'll render it. And so under ECS, type no longer matters. And that's why this discussion of
But if you define what a particular type thing needs to have.
that's after the entity component systems. What?
It's just a schema.
Let's go to BSDD. So under ECS, if we're looking at it that way, this whole, we're used to thinking about defining different types, concept as a starting point,
No, I
right?
think that could be done now, but okay, so being slow. So there's an entity, and then all it has is a UI, a UI.
That's it.
Okay. How do I know that big is a sign?
You can, well, there's a question of what's the minimum on an entity that does it have a name or a classification? Is it like that's the minimum you could put on there? Or you could actually just have a relationship to a classification that says I'm a sign.
For example, if you have a classification, I think you could have whatever, master form, uniform, you could have you, and based on that, so then everything, all the constraints relate to different. So if it has an omni-class component, and that component references the fact that it's a being, then all of a sudden it should have this. But that's like way later.
Well, so
It's relations on the components.
So I think there's two.
So there's a certain flexibility, right? Because early in the design stage, you might say, I have this entity, and I've classified it, but I don't have any other information needed. So you can actually define standards for what information is required at different stages of the design, right? And it's all, so maybe one way to think about this, right? One way to think about this is this whole question of, is the standard helpful for writing information? And is the standard helpful to make reading information useful? Because here we can very easily write out all our information in the standard, but that doesn't necessarily make it easy to read it in, right? We still got a lot of different choices and options.
right.
Right, that's the difference between the gaming world and the BIM world, right? It's, if this was truly just reference data,
Yeah.
right, then that's all you need, right?
Yeah.
Give me the geometry, I'll display it on the screen, we're done. But if I actually want to say, okay, for this particular data, I would like to create a floor slab in my system that works the way that floor slabs work in my system, then I need more, I need to understand what the information means.
Right.
And probably the two pieces of information I think that are needed is, yes, there needs to be a classification component, but there also probably needs to be, this entity was created from this template. Right, and maybe that template exists in BSDD or exists wherever it is, and then say, okay, this is the sign template. Okay, that clearly means in my system, because this is I understand sign templates, I would create a sign.
Would be a pointer to the template.
I would think so. Or something.
So it seems that the templates are something you do with an entity component system structure. It's something you apply as a separate thing. Because for instance, I would force a lot. Well, it's going to have a fire separation component with all fire separation information, right? It's going to have a structural slab component or a flat slab structural component. It's Maybe you're gonna have a sound separation component, but all that information is there. And when you have those things, you can have a system that does a sound transmission analysis, and you just ask the good model to request, give me all the elements that have a sound barrier component on it, and it will fix that. We can also have consistency checks. Does the actual physical thing conform to the sound barrier? Does it conform to the fire barrier requirements within that entity? So.
Yeah, so, well, I was going to say, like, the consistency checks will end up more on the components than on the entities, right? So you make like,
But the consistency checks are a design exercise. It's not something that the standard has to do. Like, we currently are able to design buildings where the floor slab is not thick enough to meet the design requirement, and it's coordination between the structural engineers and the architects and back and forth. Right? Right? The standard doesn't have to fix that problem for us.
Yeah, I mean, I guess where it points to is you are an acoustic behaving slab if you have the requisite components and their records. And otherwise, and so it's dynamic. Now, there is the idea of templates, but again, templates are useful, right? You can start with a template and violate it.
I think you should start, you should think of a template as like a named collection of stuff. Yeah.
I'm trying to understand, I'm really difficult to understand this, because I know the situation of I've seen people, so I'm trying to relate to it. How does it be different? Can I interpret it as a kind of small metal model we put on top, having things like element, component, scene and stuff, that stuff? When we reinterpret IFC in a more modular fashion, or hey, now we IFC as a whole, sound stuff, did stuff, all this future stuff. Now we put the kind of metaphoric archetypes on top, and we reconsider the IFC in those terms.
Well,
Is that a bit of feedback?
I can't really explain, so.
Yeah, how would it relate to current IFC? How would you?
Oh, you would model it quite differently.
So I think that's correct, right? What you could, so maybe just to give a suggestion of how we might take current IFC, we would take all the leaves of the IFC hierarchy.
Because there are components maybe?
No, we would take all the leaves because those are templates. And those would become what we're calling templates here. We would take the whole hierarchy, and we would just trim it off.
Yeah.
And we would then define a number of components. And then every leaf, instead of having a hierarchy tree, would have a list of components that are attached to it.
Right.
If we were to reinterpret current IFC in terms of this.
Yeah.
No textual.
So a component, you can have a taxonomy component. Right, because again, taxonomies are.
I think templates can have a hierarchy definition.
Templates can, absolutely.
Yeah. But basically, the whole thing explodes into
Objects.
components,
Oh, yeah.
and including the parameters.
Yeah.
Right?
Well, because we
Relations, everything becomes a
There's one more complication, it is that the entities are not the same in all processes.
correct. Well, that's it's sort of,
Different parties have a very different view on it, lift shaft or slab. I'm going to talk more about this.
right.
Presentation, but that complicates it further, that you can't have the kind of same entity going through.
Well, and this is,
You have to have something above and link together those different representations, which are different entities, and also have some kind of relation from the virtual world to the real world, because it's not one-to-one.
right. Well, so this is what you very much, I mean, the Git model is a very, if you can hold that in your head, is a very good one, because basically I have an entity and it moves into a new scene. So that's like just a commit. It's or where like it's got new information as it goes. So you have to version control the scene. Like I have these versions of these entities are what's in this version of the scene. I mean, you have to, whatever you call this thing, it's a collection that has to be versioned. And then if someone makes a new one,
You need different representation, different to the different products and geography, you need different level of detail representation depending on the scene.
Well, right, but the point is it however that's assembled is up to you. That's the point of a system like this. Is like if we go back to like something like in this example, the client scene has a classification and a relationship to a classification. If you model it that way, who knows? But just say that the scene that moved down to the design are the same entities, but they have no components. In the future, they could have more new components, but it's the same entity. There are copies that you have to know that are consistent. It's
Not really, because you have entities that disappear and then new entities coming in, so the entities are not the same throughout the process.
no, but you're thinking that the entity.
That's again.
So in this,
Is it the actual physical thing or is it the virtual thing?
so yeah.
Within the ECS world, we can organize it so that we can create an entity and then assign the component. Components can be at different levels of abstraction. So you could have a building system component, and that says this entity represents a lift shaft. And the building system component also has a property that's a list of all the other entities that are more detailed versions of it. So the lift shaft knows about all of the parts and pieces that are part of that lift shaft. Or maybe they just refer to a whole other data set that says here's the more detailed version.
And then we need a quite advanced hierarchy tools for the manager, it's not just flat hierarchy.
It has to be complex, so.
Yeah.
It's easier to do it so that every party that has its own representation publishes that representation and others use it. So, because now for a lift shaft, for an architect, it might be one object vertical, it might be for each floor, a stump that no standard specifies how.
Yeah, so the
Different, and for the structural engineer, it's probably some objects, and for the retailer, it's 10,000.
right. So what you're describing is like I've showed this as an assembly scene entity component. Is there a concept that's in between there that's like a named collection? But that we have those things. They're called groups. They're zones. They're called these things, and you could use those concepts in a scene.
So you're talking about alternate representations, right? You say there's a lift shaft, and there are alternate representations for it that might consist of a different number of entities. Yeah, I think so.
Yeah, it's different.
And also use names.
Different numbers of entities, yes.
Right.
I think the business logic that has been developed, I believe that the business logic that has been developed in IC can and should be ported to this, right? I mean, the idea that there are spaces and they have relations to walls, relations to openings, relationships to doors. I mean, some of that, a lot of that I think we should be recreating. Now, how it gets refactored into some of this is the big challenge. And I think there are questions about, like, just as an example, right? These massively differently typed relations, for example. I mean, those kind of things we can throw out. I mean, there's simplifying of the business logic as well. But I think there are reasonable steps there. But a lot of that, just what is a building and what are its parts and what are the relations? We don't need to recreate that.
I agree with that, but we need to enable that those don't need to be one database or one data set or one file. So that they can go across.
Well, so this moves. Oh, sorry. Go ahead.
Well, I think the consistent entity IDs, right, within one project, you could have 80 data sets, but because they're using GUIDs, they can all have sort of keys that cross each other, right?
The basic understanding is
applications or services.
Yeah, I can help you to understand everything happens. That was my understanding when it is study. If I mean, okay, today I see it, as you all know, it's of course very much based on my deep inheritance structure that is under critique. But I'm not quite sure whether purely reorganizing it, that's seems to me like a kind of organization process. I mean, even argue that some ideas of components are already there.
Well, and currently, actually, Thomas Kreinen, yeah, this came up because Thomas Kreinen pointed out, like in IFC 4.3, address is now a thing that can just be associated as a component to anything, because historically you have one address, but now you have anything can have an address in an entity. So like that is a perfect example of exactly this. So it's not like we certainly would reuse the concept of having an address, but no longer, you know, it doesn't automatically get associated with anything. It's something you can associate with anything. That's the distinction.
Right. My concern is that we just move the complexity from the component.
Right.
Right. Previously, we were talking about sound barriers, right? Do we have a sound barrier component? Because if we do, then we're just going to have thousands of components, which is exactly the same issue we have now, except instead of components. So instead, what we really, I think what we're trying to do is have a smaller number of components with the ability to say, okay, if you have a component that has this information, and we agree that that's sound information, then you still have to then, as a system that wants to do more than reference, or more than just display parameter value, right? You have to then know how to process that component in a more intelligent way. And that's where we need a global standard, right? Where we need a global standard for anything that we wish to have more than a scene rendered.
I think the question is, does this allow us to standardize faster by focusing on one thing at a time?
Maybe there was a few more questions I could actually put answers for my study. It's all about like, I mean, at least we and others have done this for a long time. I always say that standardization is 90% social, 10% technical. So 90% social means I need to have very good communication mechanisms to explain to people what I want to standardize and what is the topic about and so on. So immediately my question was something, is there some practical language to express it, something to share with others, getting a common opinion, so things like UML or something like a notion that helps us. Yeah, or others, our notions, whatever, some notion. Yeah, standardization is communication among people that will finally result into people understand us and common. I haven't found anything on that media listed or still under development. I don't know.
So I'm just
ECS is an high-level architecture, so it's not dependent on technology. You can use any kind of technology to implement the architecture.
Yeah, but it's not visual communication or something.
It's possible to use, I don't know.
Yeah, absolutely. It's like, I mean, that nothing is owned by a single firm, entity, company, whatever. I mean, maybe the end user, but the second something exists in the real world, it's being renovated, modified, changed. Insurance wants to do an audit and connect to that data set. So like, we have to solve that problem. And you're absolutely right on the standardization side. Like this doesn't come for free. But what I think this is all about is there actually a way to theoretically even solve it at all? And that's the level this conversation is. Not like, you know, how we make our communication to people better. That's why this is a working session that we've talked about in 3 meetings, and we sort of see this architecture emerging in other places. So if the large vendors see the reality that if they have multiple tools that have to connect together from different domains, ECS shows up. So like it is not a panacea.
It's a main use, the main industry was actually gaming and found. It's actually used also for gaming,
also intuitive tasks. What's different between giving rendering engines, gaming engines, etc.? Because they expect some kind of behavior, I don't know.
So like, look at this up in here.
How specific is it to K, or is it going to be more broadly?
I'm just asking, I don't have the answer for you at the moment.
Also,
The people here that know more about this.
Trimble, Autodesk, and Bentley are implementing such systems under slightly different names for exactly this problem. Domain or application agnostic representation of this information. So I mean, it's not we're not inventing the use of it in our domain. We're early, I would say, in considering it.
We have to look at the concept and architecture rather loose and not strictly into this, not dive into the details straight away, because I think the important thing here is the architecture, that it's distributed, the model, distributed model, and how you combine those different distributed data. I think that's the important part of the architecture.
I can imagine there are also disadvantages. There's always been this comparison between component-based and inheritance-based. And there are two worlds with pros and cons. So, but you have the feeling that this one is more towards how distributed.
Well, I think
modular.
it feels like history is on. It's trending this way.
It's trending, okay.
Was it like just to, I mean, I'm not a software architect, but as an end user, I've complained about this problem for 12 years, that every time we put a toilet in a building, we have 3 toilets, or 2 at least. Or if we put a light fixture, I have at least 3, because every entity that owns the light fixture has a singular instance in our IFC data. Will have to have 3 light fixtures that have to figure out which one controls. But I can't take position from one. I can only take the whole version of one, and I can't assemble position plus representation plus render quality. And so we're making 3 times the data, and you end up with duplicates every time. So clearly, from a collaboration perspective, it's an object-based approaches are not solving this very well.
To Thomas's point, I think the slide that's missing at the beginning of this presentation, right, is why are we changing IFC at all? Right. Why isn't IFC 5 just?
Well, I mean, maybe I said it without saying. These slides were we're being asked to solve. Sorry.
I think in Zurich we came up with some kind of criteria like more batteries, more distributed, and so on. I think I think the common criteria. Then the question is, does the change of principle helps us? Or what are the side effects? And there will be side effects.
Yes.
I mean, nothing is just perfect.
But we can't know the future unless we try it. That is sort of the problem of not.
I think one concrete requirement, which is in the discussion so far, I think it's very important that IFC will be contract compatible, that it will be possible to use IFC datasets in contracts. As it's not decided. So I think that should be more or less the highest priority for the new one. And then you have to take away this or split or not make obligatory all of this side project, blah, 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 which in most of those datasets is totally irrelevant and not needed and detrimental.
Yeah,
So that kind of changes, I think, are more.
But I also think one thing missing here, which is probably driving it in a different direction, that's archiving. Because I think archiving is a use case. It's probably a different one, but it's a use case.
I mean, absolutely. So let's keep moving, because the only other thing I wanted to just touch on was, so if we went down this road, what are we actually talking about? How this would actually have to work? So like we got the template space, like clearly the request is that whether this is actually an API that buildingSMART just makes and we don't host, we have 2 needs. We have to be able to allow application-to-application communication through a standard API on this sort of representation. But then you also have to have a storage mechanism that's not dependent on one of those. So we have to have a sort of way to sort of solve this, and I spelled synchronous or asynchronous wrong. So either you need to be able to make these connections live or asynchronously, and then you also be able to, sort of potentially, we don't have to invent these things, but we have to help think through that you might have a cached copy of these things, and then this whatever this open storage looks like has to serve, you know, the archive or sort of online sort of thing. It's not none of this is trivial.
This one seems squishy, because I think still is ambiguous what API is, and the storage will be distributed too, right? So, I mean, I'm not saying this is, I think there's some finesse.
Well, and by the way I'm saying this is not an open source service, it's a ability to store the data in an open way or in an offline.
And again, API would be a common, I hate to say standard, but maybe just a commonly shared way of apps communicating with each other, like with storage.
Right.
And what kind of technology do you fit that, like XML, RDF technology,
Well,
or JSON, whatever?
Well, we're certainly, we're proud of the work, prototype work that has been done thus far, that is just Devin Sparks from Trimble pushing on this, has been JSON LD. Because it's really good at making components, and
I can make
But again-
the links for the linking also.
But there will be multiple transmission encodings, and the basic architecture should work across those. It should work in RDF, it should work in JSON, it should be an XML way of doing
Use
this.
that technology.
Yeah.
but yeah, like you can store ECS models in SQL
Right.
rather well.
And I guess in theory, be able to ask for the data in different, I think it's part of this article.
So this is sort of just coming back to, I've collected a bunch of different use cases, but if we don't think those are necessary, time, what's our time? 20 minutes? I could just show you what I'm talking about when I say that, like just diagramming out different versions of these problems. You know, the space represented in 3 different ways is an unsolved problem because, you know, those 3 representations are in different softwares actually. This is actually some very good show. Sorry, this is me looking at this from a totally different perspective, but like the same problem on a space. Sorry about that. This idea that like I have one application, and this gets to how you describe linking these things through workflows, because we're still haven't yet to figure out the right way to talk about it. But the idea that okay, I make this space, so I have an entity. Let's say I didn't have a requirement, I just made it. So now I have an entity and I have a component that's a couple components. One is the geometry of the space, one is a set of properties. And what I want to do is actually the CAFM system wants to make a new space representation that's a different form of measurement. So what you're actually doing is you're sort of saying, well, they can ingest that as a link, they can reference it, and then they can sort of extend it or add to it, or what was the term that we used before? Enrich. And that can make a new representation. You're not changing the previous. You have 2 geometric representations now on that same entity. And what is the sort of unclear is this, like this is an implicit link, because if you have the ID, you can make the link if you have access to the others. But if you don't, this is not the case. But then you have the third example where I have, you know, sort of the energy model version of this. So the first version of doing such a thing like this is you can actually do propagate change knowledge. Something changed. You can go forward or backwards, and somebody like your data might be affected. These are some things you get from this sort of model. But at the same time, this would allow you to assemble this, and whether you ever have all 3 of these things in one place are questions. But it's like if you ever want to solve the space, like with the energy problem, we have to be able to connect the base data that makes an energy model know it's out of date. And the other way to do that is have these sort of linked relationships as well. I don't think you need the entity model to do that, but it's an important sort of benefit. We could talk about other things, other approaches, questions.
Do the component serve returns?
One more time.
Components, Is it possible to describe inheritance for components?
I,
Inheritance tree for the components.
yeah, there are examples you find when people do components have nested relationships. Definitely.
Isn't that what you're trying to get away from?
Yeah, that's.
I thought
Thomas was commenting with it, but it's supposed to have the same complexity of the components.
Well, so
Can we see that?
Well, so you can look at it a different way, like, let's say you think about location. You might use a reference to place a bunch of things. So it's one component, have a relationship to other components, but it's a flat relationship, it wouldn't be hierarchical. That's.
I would think of the different design phases of the design, and you have very scarce definition of a slab, for instance. And then in the later design phases, you have more information you want to the slab to do what marks and stuff.
That's
So maybe one can have inheritance of the component, the slab component.
Well, so this, I don't think this is necessarily a trait of the ECS model, but there's certainly an instinct that we should be also pushing towards a pub sub or publish subscribe model versus an ingest model. And so what you're describing is, I think you would as a relationship back to the other component instead of a hierarchy. Like I inherit from not I'm a sub. If that makes sense.
Instead of inheritance, you have a separate standalone one box.
Right.
Maybe, or potentially, we could just say the standard component says you may specify these 18 parameters. And if you do specify them, these are the names to use. But they're optional. So at an early design phase, you have 2 of them. At a later design phase, you have more of them. At an early design phase, your geometry component refers to a plane with an edge. At a later design phase, it's an actual 3D solid, maybe it's a mesh, maybe it's something else. And then this question of, do I have enough information, right? Which we think about from a traditional design perspective, right? At design development, is there enough information on the drawings? Have the engineers actually done their analysis? Is there enough information that we can go forward? Well, there never is, right? That's just that's a human process problem. You know, have the decisions been made and all that. So we can deal with those in a fairly heavy way by saying you cannot express the information if it's incomplete. Or we can say the standard allows you to express incomplete information, and it allows you to write unit tests, and you can write a test that goes through and says, is the information complete? Right? And so as an owner, you can have a script that gets the information, and you say, I expect this information at design development phase. And you get completely standards compliant data that allows you to call your designers and say, hey guys, there's some key decisions that haven't been made. But the standard doesn't need to enforce completeness, right? It's the whole hierarchy kind of goes away, right?
And I think it's better that the standard never goes to otherwise we very much manage the user.
Yeah, I think what I guess that's what I guess we want, but so we can.
What's like this?
The language for testing the data model.
Yeah.
Validate the-
Exactly. Yeah.
That's for the design phase and then the design
Yes,
phase.
exactly. And it goes in that definition of, if you're going to tell me you have a beam and you have construction documents, I don't believe you. Yeah.
There's probably a minimum requirement. I mean, if I give you a beam, that's really nothing. That's enough. I put a beam with
It
that.
depends at early stage.
Well, the side example from Nigel going from an asset owner to a design team is just the entities.
But it might have a location or.
I mean, it's a pool of assets that are signs.
I hate to throw out the MBD thing because it's so overloaded with baggage, right? But that idea that you have certain, there are standard sets of valid entity component relationships that you can request. seems like something we need. I think it seems like the collective wisdom of this room doesn't know how that is defined in the ECS world. But how do I define a valid graph?
Right, I think it's a check.
Okay, call what you want, but what is the mechanism for doing that? And I don't think an open source APIs are going to do it. I think there must be some way of doing it. And maybe it's Sparkle, maybe it's a Sparkle query, but there's got to be some way of saying, is this set valid? And can you give it a valid set in a way that is not software dependent? And I think that exists. I just don't know this domain well.
Well, we definitely have to realize that we're like these things, the base version that buildingSMART International provides, there's a version of that, and then there's also like
it's
Australian sign, type 1.
Yeah.
But in general, when you have this kind of standard that never forced to have exactly the level of data you require in some areas where they do, so the time they are doing some application guides, and in those application guides, they say, if you are in this phase, for this proposed cases, you should populate this data. And then it could be like this, I would say, very informative for human, or it could be built through digital ways that if you want to populate data from this phase, then you have to pass this test. And you test only the data that is required at this phase. And it's something that maybe you can envision for this approach. If we want to get the standard, never force the data you have to use, but then maybe we can have additional means, software, guides that explain that if you really want to populate data for this phase, you should have this data in mind.
I just don't know the technical method. I don't know how many of you have seen this cucumber stuff. I can only reference it based on what you guys, for the people that came to Boston. I forget who's doing this work, but there's a natural language constraint definition technology.
Gherkin, not cucumber.
Yeah, it's just another technical. But Gherkin, right? So there is, that seems to be the kind of technology that you need. There's some sort of ideally natural language, human readable.
It could also just be a list of these things that have the component, the type component of this name need to have these components, and they need to have these. There's a list of components and properties that must be present.
No, Word document? Ideally not.
Hopefully a text document. Yeah.
Well, it's in computers.
Yes, exactly.
And operating.
But isn't that already in IFC with the cardinality restrictions? So, but I don't know how.
I think part of the problem should be, one thing IFC has done is to mangle the schema and the constraint together. And these constraints are.
That's what you market separately.
Yes, and there's really should be I think there's
the
the base.
constraints and the constraints in a certain usage.
There's the base data architecture, which is some version of this ECS thing. There's the set of components, which maybe is something that can live on BSPD. There's a pure kind of syntax validation mechanism, which is like whatever the equivalent is XMI. And then there's like the actual rules, these where rules, which have never been. I mean, the whole thing got put together in one monstrous file, but only partially, right?
So you want to
Break it apart into really three separate
a
technologies.
bit like big data, you can have audience owl and then separately shape on top of that for certain purposes.
Yeah, we're not the only people that
That's not exactly true. There was always the idea that there's a minimum of constraints built into the schema, but it was just the minimum, like no two projects or
By definition,
something extremely minimum, because it's, if you want to have a data schema for the entire life cycle, there's hardly any information that is required. And yet that's all times in the life cycle, there's hardly, I mean.
But still, we should, no offense, all due respect, I mean,
Probably
what
mainly in geometry,
Yeah.
like,
it just doesn't make sense for the minimum and completely different.
and the idea to have more usage related constraint, that was the idea of this sort of
Sure.
what the 10%, so that for certain usage, you will then add certain requirements.
But that's like a business logic decision, distinction.
And maybe
Not
it can be done now in a more, let's say, better technology way, but that was the basic idea. So the built-in constraints in IFC were absolutely minimum. And everything else was meant for
They were universal, they always have to be.
Yeah, the
Otherwise, it's nonsense.
Yes,
Yeah, I'm hoping what we're talking about is transitioning technology, not getting rid of.
Right.
yeah,
Right.
Yeah, the minimum and the desire, yeah, that's what I said, the business logic should persist. So whatever the minimum is, there should be a way of describing that. And maybe that's what you're sort of referring to, which is like, you know, you've got to actually write an exporter, right?
Right.
So what are you asking, what are we asking you to do? There's got to be some way of declaring that. And again, I don't know what that technology is, but it just feels like, you know, with all due respect, and a huge respect, the minimum commonly held and the extended minimums should be completely different technologies in today's world. They don't need to be.
Right. My big concern with IFC today, right, is that every single implementer of IFC is a different dialect of IFC, right? Because there's enough flexibility within IFC to allow you to have some interpretation or some, this isn't right, or some, I'm going to fix this data. That's all kind of there today, right? So I would like to see a system in the future that minimizes that. So we do need to be careful about having some subset of it, which is a global standard. And yes, the flexibility to add the Australian road sign, the Queensland, right? Because Queensland.
New South Wales and Queensland, they fight all the time.
Right, the Queensland road sign, blah, blah, blah. And you want to sell software in Queensland that does road, then you better know how to deal with the Queensland road records. But if you generically want to display beams and walls and floors, buildingSMART can handle that.
But what it's sounding like is that's not going to be baked into the schema. That's going to be some set of definitions with the technology that we're going to define as a standard.
I think so.
And hopefully you can bang on any piece of software you interpret it straight with.
Yeah, and going back to that middle discussion, do we write down what a component looks like? Do we, with library, or do you have an API for the centerline based geometry for a wall as a standard API? And that geometry is a component that gets attached to a wall, and whether that's genericizable or not, I don't know. But it could be, you know, like you need those kinds of specific components for specific types of things, or you have generic ones that are just like I'm a B rep, or or in the future, if people actually want to do parametric definitions, fine, because then you actually can, you know, you can add them as needed. But I think you end up wanting to have those as, whatever we do, APIs that can define those specific components.
Yep. Right, and that's the business logic that I hope we preserve, right? I would hope that we would have some global standard for how we define a linear wall of one material, right? Whereas a clockoid-based offset wall, yeah, that might be something you would define in New South Wales or whatever. And
I think because of the implementer, what we should be able to do is have technologies where we can send you arbitrary requirements. I mean, even the idea that there is a single IFC exchange requirement, minimum viable, I'm not sure that's, I mean, we should have a catalog of requirements that buildingSMART manages.
Yeah.
Technologies that allows other people to extend those. And a query mechanism where we can ask you through a common API for a set of objects, be they buildingSMART sanctified or otherwise, and all your software should be able to do. You should just have to deliver the data based on that query.
right,
And when we come up with a 4.3, 5.6.3.2, you shouldn't have to change anything. It's just another query we give you.
right, and then the alternative is I don't know what you're asking for. In which case, as users, you say, hey, you're not supporting the clockoid-based wall. Please add that ability. And we say, okay, now we will support this clockoid-based wall because there's a new component that we haven't seen before.
Yeah. And the query should, you know, return some, you know, some level of, you asked for a bunch of stuff, you know, I didn't have all of it. Right?
I didn't have all of it, or here's a generic version, right?
Right.
do with those. I gave you a mention, because that's all I do.
So we're in the middle of, yeah, so we should wrap up. Any final thoughts from anyone?
Sorry, still talking. But it seems that the ECS, the identity component system, what's unique about it, it's not solving all the problems, but what it does introduce that we don't have now is it allows us to distribute ownership of the data of one entity among multiple people, so that different disciplines can contribute information and own the information to that. And it allows us as well an easy way if I'm writing a reader, if I only care about certain types of information, I can just ignore the rest, right? Whereas now, if there's in the hierarchy, I've got to read and understand the entire hierarchy all the way up. And I can't just be like, okay, I want to know about all the products, because product is the thing that has the information I want. I'm going to read all the products, or I'm just doing a 3D render. Give me everything that has a graphic component. And so those are the benefits of the ECS approach. And it doesn't necessarily solve the hard problems of standardization and, all that kind of stuff.
Again, I'm repeating myself, but I'm floored by the amount of useless garbage placeholders that on Health has to provide, because that's the standard, right? It seems like, well, we don't carry that information, so okay, we'll give, what is an example, right? I mean, so many times the value of the parameter and the parameter name of itself are the same, because you don't have it in there, so you just say, okay, we've got it. I mean, so the standard has survived, but it's produced a lot of garbage workaround and garbage data, because it's not flexible to it.
That's what we go to the schema. That's the main complaint I get from our implementers, that they have to put in garbage. Yeah. Because but that's the certification and then it is required, not the schema.
Right. We don't need to have that one. So this afternoon after lunch, we'll have, in order, Autodesk, Trimble, Bentley talk about similar ECS-based models, where Leif's going to mention a few things, and then Devin will join remotely.
That's our conversation.
Thanks all.